Let's talk about memory in C# and in Java, these very high-level languages. Memory is generally automatically managed for us, though it's important to be aware of what's going on in memory to some extent and to also understand where your memory is being allocated from. When we begin our program, and this is a very basic program obviously, the operating system sections out a chunk of RAM for us and says this is going to be your RAM. And inside of our process in the operating system, we further subdivide that into three categories, two of which I'm going to talk about in this video. One is the stack. All right, I'll call this the stack. And the other is the heap. All right, and I'll just draw a line between the two. In no shape or form are they the equal size or that kind of thing. It's just that's how my drawing ended up. The idea with the stack is as you declare variables and call functions, that thing, the stack will grow. You can think of it. The typical example is like a stack of plates at a cafeteria. You put 5 plates on, and then you just take the plate off the top as people go by to collect food. They'll take whatever plate is available. So the stack generally grows as we add to it, and it shrinks as we take away from it. And in theory, it doesn't really matter which direction it grows, but I'll just draw it growing up and growing down because that makes sense because gravity is at the bottom. The heap, on the other end, we can put data wherever we like. All right, and actually we don't put it anywhere. It's when we call the new operation in certain circumstances, the new will go out and find some room. And so I could put a cat here and put a dog here and a cow here and maybe another dog over here. It doesn't grow up nor down like the stack. The heap's just kind of free form, and there is a allocation algorithm to it, but for now I'm not going to get into all those hardcore details. We're going to keep it simple and then add the details later. So let's go into main here, and I'm going to say int my int gets 5, and then int another int gets 10, and let's do double me double gets 98.2. That's a 3. 98.3. Okay, we'll go with that. Well, what happens as far as the stack is concerned is when we execute this code, in fact, I'll hit F10, start the debugger here, and get rid of these windows on the side. You can see right now we have our debug arrow at the beginning here saying we haven't executed any of this code. When I hit F10, now the runtime has to say, oh, okay, we need to make some room on the stack to hold an int. Do you remember how big an int is? An int is 4 bytes wide, okay, 4 bytes big. So I need 4 bytes on the stack, big enough to hold an int, and we need to initialize its value to 5. All right, so I'll hit F11, and let me just kind of animate down here what's going on. We've added an integer. We called it my int. I'll abbreviate a little bit, and then we stuffed the value 5 into my int. So there's the stack. All right, and now we're going to say, ooh, another int. Well, another int. Here we go. We'll just add it on top. This is another int. And let's be consistent with our casing. How about that? Another int, and we're going to stuff 10 into there, and it's 4 bytes wide as well. So you can think like 1, 2, 3, and 4 bytes. These are all 4 bytes wide. I'm just kind of putting these tick marks up there. So when I execute that, sure enough, our stack now has another int. And then I say double me double. And a double, if you remember, that is not 4 bytes, it's 8 bytes or 64 bits. So that's actually going to take up more room on the stack. Enough of 2 ints worthy of stack space, if you would. So there we go. I'm just kind of abstractly drawing these tick marks. So we see 1 byte, 2 byte, 3 byte, 4 byte, 5 byte, 6 byte, 7 byte, 8 byte. And then we're going to put the value 98.3, and I won't talk about how floats are represented in the computer, but 98.3 will be stored there. And then we're done. All that RAM for all 3 of these instances of these int and double types are stored on the stack. Now, an interesting thing happens when I hit this closing curly. Understanding scope, you realize that when I leave this function main, I can no longer reference any of these variables. So at that point, when I hit the closing curly, the stack must unwind, which means all the stuff that came into scope while we were executing that code disappears. And it disappears top bottom. I know I kind of erased that kind of haphazardly, but literally it unwinds from the top to the bottom. Let me do another illustration, see if we can come up. Let's do a function here. Static void goo. I better uppercase this because I'm in C#. And here I'll say int GUI int gets 29 and double GUI double gets, I don't know, 43. Why not? And then in here I'm going to, let's call goo here, and we'll also call goo here. All right, so what's going to happen with the stack as we're going through and executing this? Maybe pause the video and think about that before I actually walk you through the implementation. All right, I'll hit F11 and step here, and oh, we have myInt, so let's put myInt on the stack just like we did before, 4 bytes wide, and I'm going to ignore the sizes of these things for this illustration here. So we got myInt. The value I stick in there is 5. And then we say, ooh, another int. Well, all right, another int. All right, another int. And the value we'll stick in there, we're stuffing in there via the assignment operator, is 10. So we'll put 10 there. And then, ooh, look, now we're going to call goo. I pressed F11 to move it on down. Goo, now the instruction pointer will go up to this function goo. And we say, ooh, int GUI int. All right, well, here's another int. All right, we call it GUI. Or I call it lowercase g. GUI int, and I stuffed a 29 in there, like so. And then right here, GUI double. Well, here's our double. All right, I'm going to just draw it like that instead of all 8 bytes wide, and that's GUI double. It looks like we're putting the value 43 in there. I could have put 43.58 if I wanted to. Step, and then now we hit the closing curly. And at that point, the runtime has to unwind the stack or all the variables in goo. It needs to take them off. Right? We're done with all these variables. So by actually hitting F11 here, you'll see we return down to here, and the scope of GUI int and GUI double is gone, so the stack unwound, like so, all the way back down to another int. And myInt, you can see they're still sitting on the stack because they're in scope and main, so they're still taking up room as far as the stack space is concerned. All right, now we're going to add me double. All right, so here is me double, like so, and we're putting a 98.3 in there. And then looks like we're going to step into goo again. So we go into goo and ooh, int GUI int. All right, let's put this right here. GUI int. All right, 29, just like we did before. And then GUI double. Well, right up here, here's GUI double, like so. And that's 43. So you can see our stack has grown significantly as we've instantiated these various types and various scopes, and it's grown upwards. And now we're going to go back and take some off. You can see that before we had a GUI int kind of hanging out here, but now we added me double, and then we called goo again, which basically means me double is taking up the place of GUI int. Me double is taking up the same RAM that GUI int took up when we first called goo, but now we bring me double into scope, and when we do GUI int and GUI double again, they have to move upwards because me double's kind of taking up some room down there. So that's pretty much how the stack works. It just grows up and down accordingly. Let's hit F11, and we're going to leave goo, which will unwind the stack and take off goo's members one by one. Pop. That's called popping the stack. We're popping variables off the stack. Then we're back here in main, and we're going to hit mains, closing curly. Well, once main exits, we don't need me double, another int, or myInt, so bye-bye me double, pop, bye-bye another int, pop, and bye-bye myInt, pop, and then the stack is empty. All right, so there's a brief introduction to the stack. If you're a hardcore computer scientist, you'll know that I'm leaving out a lot of details, but the semantics, which is another technical term, but basically semantics. It's just a fancy way of saying the meaning. So the meaning of what I've taught you here is correct for sure. These variables take up room and they come to scope, and the stack will grow, and it will also return accordingly. So there you go. That's the stack. And in the next video, I'm going to compare that with some behavior that we'll notice on the heap.